And the McDermott group at Northwestern University, which is the top clinical trialing group for peripheral artery disease, maybe anywhere, did a trial of nicotinamide riboside versus placebo versus NR plus resveratrol, by the way, as a third arm. And they found that nicotinamide riboside met their primary endpoint. So it improved walking speed for the NR group versus placebo. They had a better walking speed at the end of 26 weeks. The folks on placebo had a worse walking speed after 26 weeks. When they did the stats, they met their endpoint that was pre-specified. It was pretty impressive.
Hello, Dr. Brenner. You are a professor at the City of Hope National Medical Center, where you study NAD metabolisms and systems biology. So, thank you so much for joining us today on Modern Healthspan.
Thanks. It's really a pleasure to meet you and to help educate your wonderful audience.
Thank you, Dr. Brenner. So, I think one of the questions to start with is, does NAD decline with age? As I've seen some papers, it seems to be an article of faith that it does. But when I actually look for papers, I find very few that actually show this.
Right. And most of the clients in those papers are mice, right? That were conscripted into the study and had their livers, taken away from them. And most of us humans don't let people mess with our livers. What I can tell you is that blood NAD is pretty stable through human lifespans. There are a few people that are walking around with low blood NAD, but they have mitochondrial disease. They already know that they have a disease. It's not a function of age. We do think that tissue NAD becomes challenged in many different tissues. We know that human alcoholics that donated liver for various reasons. They had surgical procedures at University of Manchester, basically. We know that the alcoholics have a compromised hepatic, i.e., liver NAD system. We suspect that in noise-induced hearing loss, that cochlear NAD declines. It may be true that brain NAD declines or that the redox state of the brain NAD system is disturbed in aging. But really, what our laboratory talks about most is that the NAD system becomes challenged under conditions of metabolic stress, like inflammation and infection are probably the two best examples.
When you say challenged, is reduction in NAD the only thing that challenges it, or are there other changes to the homeostasis, like the NADH um, ratio?
And it's complicated because that's literally called reducing NAD. Reducing NAD is adding two electrons to it and it becomes NADH.
Oh, not yet.
But but what but here's a great way to think about it. In 2020, March of 2020, when I was sitting in my office at the University of Iowa and got the emails that we all got that most of us are going to have to go home and we can't continue to work in the laboratory. One of the ways that you could keep on working is if you were doing something with coronaviruses. Well, as it turned out, we had data sets in our freezers and in our computers of what happens to a mouse that is infected with a coronavirus. And we had that because we were one flight of stairs above Stanley Perlman at University of Iowa, who was one of maybe only three or four virologists in North America that knew what coronaviruses were. And like, who knew about, was anybody talking about coronaviruses before COVID-19? Very few people were. And what we found, so we were able to stay in the lab and do those experiments. And what we found is that the double-stranded RNA that comes from COVID basically challenges the NAD system. So cells, mammalian cells, have something called an innate immune system. The acquired immune system are antibodies, right? You have to present an antigen, make antibodies. There's B cells that make those antibodies, et cetera, et cetera. And those antibodies go and they try to, capture bad stuff, clear it. But the innate system responds to weird shapes that the body, weird molecular structures that the body knows are foreign. Like there's something called lipopolysaccharide from bacteria and double-stranded RNAs that come from viruses. So when mammalian cells see a double-stranded RNA, what we discovered is that they turn up gene expression of five different members of what's called the PARP family. And these PARP enzymes, and these are not the famous PARPs like PARP1 and PARP2, but these new PARPs that we described, they churn NAD. So they take NAD and they try to stick an ADP ribose unit coming off of the NAD onto the virus or whatever the cell is perceiving is attacking it. And so, in the course of a response, an innate immune cell's response to a coronavirus infection, our NAD system declines. And then, in fact, the nicotinamide riboside kinase genes that our group discovered and some other genes involved in NAD synthesis get upregulated. And the nice thing about doing this research is that it suggested, I mean, we did the experiments in vitro showing that provision of NR, nicotinamide riboside, would protect cells from allowing a lot of viral replication. And what that did is when folks in Sweden, read our preprint, they said, let's enroll people in a clinical trial to see if nicotinamide riboside and some other compounds accelerates time to recovery from COVID, and they found it does. So, so the use cases of nicotinamide riboside come from conditions of metabolic stress in which the NAD system is under attack and provision of oral nicotinamide riboside basically restores resiliency and homeostasis.
Low NAD. There was a paper in April, I think, this year from Chubanava et al. That showed that 85% reduction in NAD did not make any difference. Oh, yeah, there was no noticeable difference to their muscle function. Have you seen this paper?
Yeah, so it's a mouse paper,
Okay.
and there's things that you can do, and mice are very resilient, little creatures, and they didn't get the expected result. So they knocked down muscular NAD very substantively. One of the things that we've noticed is that the mitochondrial NAD pool is pretty well protected. And I think that's why muscle function was maintained. They didn't do any particular challenges. So I think that if you were to challenge those mice to various recovery models, you would see some deficits. These are the crown jewels of metabolism, and they are exposed to many conditions of metabolic stress, but a little bit of the key NAD coenzymes can go a long way in a mouse muscle system, is what that paper showed.
Right. And NAD is in separate like compartments in the cell. So it could be sufficient in the mitochondria, but not elsewhere, perhaps.
So yeah, so there's two big pools that we think about but there's a couple of others that are kind of mysterious still. So we think about a mitochondrial NAD pool. We know that there's an NAD transporter into mitochondria that will allow NAD that's made in the cytosol to get in. And then people like me tend to think of the mitochondria and then everything else, meaning the nuclear NAD pool and the cytoplasmic NAD pool. In addition, there have to be NAD pools in the what's called the endoplasmic reticulum, where steroids are made. A lot of other kinds of small molecules are made that depend on NADPH. And then in neurons, it's pretty clear that in neurons, the cytosolic NAD levels can be different than the nuclear levels because you can have in your sciatic nerves, so right around your hip, you have the nucleus of a peripheral nerve that goes to the tips of your fingertips or and the tips of your toes, and you can imagine how long that is in a giraffe. So there are very long axons, the nerve projections where the cytoplasmic NAD can be different than the nuclear NAD. And one of the things that's really quite interesting that's been discovered is that NMN, which is an intermediate in the synthesis of NAD, accumulation of NMN can actually kill and destroy those axons. So there's a protein called SARM1, and when NMN accumulates, it can lead to axonal destruction. So I've never heard any of the NMN aficionados, comment on this literature, but it's a known fact that NMN accumulation leads to axonal destruction in peripheral neurons. So yeah, there are different NAD pools.
Do we see that NAD disturbances are related to diseases of aging, in particular, like diabetes, cancer, metabolic disease?
Um, so let's start with a much more common one, peripheral artery disease, right? And the reason I'm really struck by peripheral artery disease is that there are now, 10 or more positive randomized clinical trials of nicotinamide riboside in humans. There's some negative trials out there, but you learn quite a lot from the ones that are positive. And there's 8 randomized clinical trials that show anti-inflammatory activity of nicotinamide riboside. Some of them are in healthy older adults. Some of them are in folks with disease and conditions like heart failure. There's anti-inflammatory effect of NR. But when you talk about common diseases of aging, peripheral artery disease is really a big bucket. I mean, we're talking about 8 to 12 million Americans, generally older. A lot of them are current or former smokers. The men typically have erectile dysfunction. These are older people that get fatigued. They can't walk for long periods of time without pain. In advanced cases of peripheral artery disease, somebody could have an infection that doesn't heal and and that could lead to an amputation, right? Because they have a wound that doesn't heal. When you do a clinical trial in peripheral artery disease and somebody is assigned to the placebo arm, 26 weeks after the trial is initiated, i.e., the time when we're measuring primary endpoints, the people on placebo do worse in a 6-minute walk test than they did at the start of the trial. And the McDermott group at Northwestern University, which is the top clinical trialing group for peripheral artery disease, maybe anywhere, did a trial of nicotinamide riboside versus placebo versus NR plus resveratrol, by the way, as a third arm. And they found that nicotinamide riboside met their primary endpoint. So it improved walking speed for the NR group versus placebo. They had a better walking speed at the end of 26 weeks. The folks on placebo had a worse walking speed after 26 weeks. When they did the stats, they met their endpoint that was pre-specified. It was pretty impressive. And actually, just in the last few days, not sure when you're going to air this, but we're speaking on the 12th of November of 2025. Just in the last week or so, McDermott and coworkers also did a trial of metformin and it failed. Okay, it failed to improve walking speed in peripheral artery disease. So I think that peripheral artery disease is the most striking disease of aging for which nicotinamide riboside is positive. But then I would say in a big bucket of all of the diseases for which inflammation contributes, that there's 8 randomized clinical trials showing activity for NR. So there's really a pretty strong use case now for this evidence-based supplement.
How does NR lower inflammation? I mean, basically, so its function is to raise NAD. Does it perform any other function in the body?
Well, NAD is the central catalyst of metabolism. So when when there's DNA damage, NAD is being used by these PARP enzymes to assemble DNA repair systems, and so under inflammatory and damaging conditions, NAD is helping your body sort of play defense, and you're maintained in an inflammatory state. And when you can get these NAD coenzyme levels up, the inflammatory conditions tend to resolve so that NAD coenzymes are back to what we want them doing, which is converting calories to ATP and to biosynthetic reactions. Making muscle, making nucleotides, making lipids, making androgens, making estrogen. Those are all of the things that NAD coenzymes do.
I think it also showed lowering blood pressure in hypertensive people. Is that correct?
There's an early study from University of Colorado, Martens and coworkers, where there was the folks that they were enrolled. It was like a healthy adult trial. And in a healthy adult, what are you looking for, right? Like I'm 64. If you test me, I don't have diabetes, I don't have high blood pressure. I'm not sure you can make my, blood parameters, much better than they are now. There's some dumb trials out there where people went and they said, gee, I wonder if we give people a supplement if they will improve their grip strength in 21 days without, giving them any workout. That's a fail. But in that trial, when they looked at the inflammatory markers, they found, oh, it lowered their inflammation. In this first healthy aging trial at University of Colorado, people were healthy. They were healthy before, they're healthy afterwards. But when they did a subgroup analysis and they looked at the people that had moderately elevated blood pressure, they weren't so high as to be medicated, because if they were medicated for blood pressure, they wouldn't have been enrolled in a healthy adult trial, right? But those folks that had a moderately elevated blood pressure had their blood pressure improved. So that's an exciting result.
I know that in mouse models, uh, Neil, Wilhelm Bohr, Dr. Wilhelm Bohr, was looking at NR for um, Alzheimer's. Did that ever move forward? And have we seen
It
NR
was
in Alzheimer's?
probably ataxia-telangiectasia and various other kind of progeric diseases in which there's rapid aging. And there is an ataxia-telangiectasia trial that I believe is running in Norway. There's also a big Parkinson's trial that's running in Norway. The initial Parkinson's trial showed a signal of improving cerebral blood flow. Very small trial, but it was very encouraging to the Norwegian government. They looked at the data and they said the folks that were on placebo, they need to get some blue bottles here for participating, and they were able to provide nicotinamide riboside to all of the participants. At that point, Dr. Harris Chulampus, I can't pronounce his last name, uh, designed a much larger trial. I think it's called NAD Park, NAD Park, and they should be unblinding their data anytime now here in the end of 2025, such that we'll be looking at whether nicotinamide riboside has activity against Parkinson's. There have been some trials in mild cognitive impairment. I think most people with mild cognitive impairment probably have Alzheimer's, but I think the idea is to try to enroll people early in the process. If you enroll people with late Alzheimer's, there may not be, that much you can do for people.
So I certainly understand that in a clinical trial, it's very difficult to see whether a healthy person gets any better. So, what would your thoughts be if we show that uh, nicotinamide riboside helps with, say, Alzheimer's or Parkinson's, that it be used in a preventative way? Would it, do you think it would have any benefit for healthy people to lower the risk of some of these diseases?
Well, you could lower the risk of if you lower the risk of flu and you lower the risk of COVID, and if you potentially address symptoms of long COVID, if you lower chronic inflammation, if you accelerate wound healing, you would be improving quality of life for large numbers of people. So the proven use case for nicotinamide riboside is anti-inflammation and strong suggestions that it's helpful for peripheral artery disease and COVID recovery and these other things. So I don't talk about lifespan extension because, you can't do a trial that would demonstrate that. If you're asking humans to do a trial on human lifespan extension and you want us as the investigators to live longer than the subjects, we would have to enroll people that are 105 or so, right, in order to kind of see the effects. But people that are 105 are probably not very typical of the rest of us. They were somehow dealt a deck of genes that is uniquely suited to, aging well into your 90s or hundreds. I think that many of us are going to age well into our 90s and are going to get to 100. But I don't know how you would enroll a trial whose primary endpoint would be longevity unless it's an extreme population.
I was going to get to it. Let's talk about that actually. So, in I agree with you in terms of having some kind of a trial that would give us longevity in humans as an endpoint. This is not practical in any way. What kind of data do you think there's no point looking for it, or is there what kind of data would make you think that some intervention would be able to lengthen a lifespan?
I don't, really speculate on that because I'm more interested in the you know the science of the possible rather than the science of the impossible. I'm interested in, improving people's lives and fitness and functional metrics like walking speed. And I mean, in the context of peripheral artery disease, you know, the people are effectively exercise intolerant, right? Because, if they can't go more than, a tens of meters in 6 minutes, they're not, you know, able to raise their heart rates. They're not able to really stretch their legs and get the kind of workout that we would like them to get. And so, if you can do an intervention that improves people's walking speed and stamina, there's going to be a feed forward effect of that in which they are more capable of moving their body and they get all of the beneficial effects of exercise. So, I'm excited about interventions like GLP-1. I, I am well aware of data showing that it combines extraordinarily well with resistance training. I think that nicotinamide riboside also has a place in promoting walking speed and exercise tolerance. And so to me, that's a really great way to improve human health.
Have there been any trials in healthy people with nicotinamide riboside and physical performance? I mean, so this was a 6-minute walk test, but in healthy people?
Like NR is a
Uh,
performance enhancing drug or something like that.
yes. Yeah.
Um, I don't know. I think that there are sports teams that have data on this that they don't really publish. A few years ago, the New England Patriots famously had a 40-year-old quarterback. At the time, their chief brain health advisor was my friend, Dr. Rudy Tanzi at the Mass General Hospital. There's many photographs of Rudy Tanzi on the sidelines of the New England Patriots. There's a couple of photos on the internet, if you look hard enough, of Rudy Tanzi and I with Bill Belichick when he was the coach. And so the Patriots, are known to have been, taking Niagen. And the trainers, may kind of have data on, concussion recovery and physical, data with NR, but I don't know of any randomized clinical trial that's been organized with those types of endpoints.
Some of the trials used pterostilbene uh, with with NR, and I think you mentioned one with resveratrol.
Oh, by the way, I forgot to say, the addition of resveratrol to nicotinamide riboside degraded the positive effects of
Okay.
nicotinamide riboside on the 6-minute walk test. I think actually the compliance was lower. There were more people that didn't take it every day. I think it causes people to poop something. I don't know what it is, but pterostilbene, there's data showing that it raises low density lipoprotein cholesterol in humans in a dose dependent fashion, in a time dependent fashion. Um, that's bad cholesterol. And the therapeutic hypothesis around pterostilbene or resveratrol is that they're SIRT1 activators. Sirtuins are not longevity genes, so it's kind of a bankrupt hypothesis. And I don't think there's really a use case for either pterostilbene or resveratrol for humans. And they don't do much for mice or flies or worms either.
Right. What trials would you like to see being done
Mm,
in
thank you for asking.
in
I
a
would
in
love to
a
see, because you know what? I like data. I like getting data, right? And the trial that I proposed to the NIH was a wound healing study. So remember, let's go back to your first question. You said, what's the evidence that the human NAD system declines in aging? And I said, well, no one's donating their livers. I happen to have gotten some livers of people that had alcoholic liver disease and adjacent normal liver from people with cancer who had surgery, and the adjacent normal liver had kind of normal NAD levels, and the alcoholic liver had a depressed NAD system. So, does the human NAD system decline in conditions of metabolic stress? I can say yes. But I think that skin is a tissue in which the human NAD system may, in fact, decline. And there's very good evidence from mouse systems as well as anecdotal human systems that wound repair, so recovering from cuts and scrapes, is much more rapid in people and mice that are taking oral nicotinamide riboside. So my idea was to take shave biopsies. These are things that dermatologists, when somebody goes in with some kind of a bump lesion, could be a tumor, but it could be a nothing. They do a very defined shave of the skin, and then the pathologists look at it and decide is this benign or malignant. And we wanted to take the benign shave biopsies and measure tissue NAD in them, see whether people that do tanning have a depressed NAD system. I think they will. People older may have a depressed NAD system. It also may be related to the cumulative sun exposure that they've gotten. So maybe where the sun don't shine might have a kind of fresher NAD system than on, the top of my bald scalp, although I'm not sure I would want to donate a shaved biopsy from the top of my scalp. But people come in to City of Hope to the dermatologist literally every day and get shaved biopsies. So we could get those samples. And then we could also measure over the course of 2, 3 weeks by photography that people could do largely at home, whether supplementing with nicotinamide riboside accelerates the wound healing. That's one of the key trials that I would like to see done. And it doesn't take years to complete. An individual's data would come in over the course of 3 weeks.
That would be good. So you said, I think it was metabolic stress. Things with metabolic stress get better with NR. As we get older, do we just naturally have more metabolic stress? So if I'm in my 50s and 60s, would NR potentially help me just continue?
For sure, there's more chronic inflammation as we age, right? And the people that love the hallmarks of aging type figures, put inflammation as either in the center or, in contributing factor to multiple types of aging. And so, yeah, we think that inflammation, or some people use the word inflammaging, is a central component of aging. It's a central component to responding to conditions of metabolic stress, and NR has a proven use case in being an anti-inflammatory in humans.
So turning to practicalities of supplementation. So somebody wants to take NR. What doses do we have data on in humans?
From our first earliest work, we provided data on 300, 600, and 1,000 milligrams per day that were taken in the morning by healthy adults. You got a dose-dependent increase in blood NAD from those doses. We now have safety data um, in a number of populations to 2 grams per day. I think in the Parkinson's world, they may have gone even higher, up to 3 or 5 grams per day. Most of the clinical trials are being done at a gram per day. And, your consumer dose is more typically 300 milligrams, but there are people that take two or three of these, 300 milligram capsules. There's a kind of a higher formulation where it comes in 500 mg doses. Effectively, it's a dose-dependent increase in NAD. There's no really safety signal that we've seen in placebo-controlled trials, but by which I mean that if you enroll, 50 people per arm, taking a placebo for some number of days versus any type of active, whatever it is that they're taking, there's going to be a few tummy aches, right? There's going to be a few days where some of the people have a tummy ache, a headache, didn't sleep well, and that's going to populate the placebo control arm. So what you're looking for in a safety study is you're looking for an excess of those types of adverse events that is found in the test uh, drug that's being tested, and that there's dose-dependent increases in it, and it's clearly different than placebo. And we've just not really seen um, anything alarming in the safety trials of NIGE and nicotinamide riboside.
You said that the blood level of NAD is dose dependent.
Yes.
Is there a plateau? Does it just continue? Or, I mean, can we have too much NAD in our blood?
I don't know what would happen, if you kept on going. If you do rat toxicology, there's a point where, nicotinamide itself becomes toxic, very high doses. And so, I consider, 1 gram to be a high dose of NR. And I don't think that, you know, I don't think that people really have to go higher than a gram, given that the trials showing anti-inflammatory activity have largely been done at a gram. I would say that that's a pretty nice, healthy, high dose of Niagen NR.
What is the bioavailability like? And is NR absorbed whole?
It contributes to liver NAD as nicotinamide riboside in a manner that's distinct from nicotinic acid and nicotinamide. Then after the liver, then different research groups are kind of jousting a little bit about that. There's some groups that say that NR is disassembled in liver and it largely circulates nicotinamide to other tissues, but that doesn't really make sense to me because when we did at least in a mouse, it doesn't make sense because when we did, a mouse heart failure model, we saw that an enzyme called NAMPT declines in the failing heart, and an enzyme called nicotinamide riboside kinase 2, NRK2, goes up in the failing heart, and that NR, but not nicotinamide, can restore the heart's NAD system. So we think that some of the oral NR is getting to the heart as NR, but human data are pretty much lacking. We know that it's being tested, as a supplement for neuroprotective effects, right? And we know that it, boosts brain NAD, I think, from magnetic resonance testing experiments. But you can't chop up people in the ways that you can chop up mice. So we don't have all of the data.
The Has anyone done like a label testing? So label NR with extra with carbon 14 or something. It's not carbon
13, yeah.
14,
Yeah, we do.
13 carbon
Yeah,
13.
we do 13. Yeah.
Yeah, and seeing where the two parts, the nicotinamide and the ribose, go.
Well, we have data that we published showing intact NR contributing to cardiac, i.e., heart NAD from that exact experiment going back to 2016.
Yeah, and I was going to say, yeah, so NRK is the enzyme that converts NR
NR to
to,
NMN, yeah.
to NMN, right? What is the best time to take NMN, NR? Is it with a
Um,
meal or without?
I don't think it matters. That's not been formally tested. But I mean, this is a water-soluble vitamin and it doesn't need fat, for absorption, doesn't need food for the biosynthetic pathway. So I think that whatever a person wants to eat with it, or I have my coffee and breakfast.
Right. So I do we see that NR raises the NAD in muscle? But I guess that would be in mice. But does it get into the muscle?
Um, does it does what we say expands the NAD. It does increase NAD metabolism in muscle in terms of seeing a higher flux. Um, in it NR expands the NAD metabolome in liver and increases muscle NAD flux. So it looks like the liver is better at actually boosting, um, the NAD system. Now that they have some of these mouse models that have a depressed, muscular NAD system, that would be a good system to, test the effect of NR on boosting a challenged NAD system in the muscle, which I would expect it does.
Right. And they created that by disabling NAMPT, right? Which
Yeah,
is,
they created it by, knocking some genes out. Yeah.
yeah. And NR comes in after NAMPT, which is why it would work.
Hmm. Hmm.
Yeah. Do you think, almost everyone takes it orally. Are other delivery mechanisms, would they be an improvement or not?
We don't know yet. So there is now an intravenous product called Niagen Plus. The CEO of Niagen learns that people were taking intravenous NAD and that it was painful. Talk to me about it. I said, oh, yeah, that's an inflammatory reaction. It's very similar to the reaction that you get from a virus because these innate immune cells are not expecting to see NAD circulating. NAD is normally inside of cells, and when cells see extracellular NAD, they kind of get alarmed and shoot off an inflammatory reaction. So there's this kind of hot, painful, hours-long process of delivering NAD. Um, During that time, what is almost certainly happening is the NAD is breaking down to NR, which is getting into cells. So what Niagen decided to do is to make an ultra pure NR that can be delivered by an IV. And so now you can walk into, you know, various clinics or call somebody to come to your home and you can take an IV NR drip. Some people swear by them. There's far more data on the safety and efficacy of oral NR than there is from intravenous NR. But intravenous NR is kind of having a moment. And, I've seen events in Beverly Hills and New York City where people are going in for these things. And we were invited to go to Yankee Stadium where there was a lot of interest in this among the athletes, some of the kind of high performance people were taking intravenous NAD and have kind of switched to intravenous NR. But really, there's not enough peer-reviewed data for me to tell you that there's a superior use case for taking it intravenously. It might get to various tissues in a more efficacious way than oral NR, but we don't have the data to say that right now.
Do we naturally have NR in our blood system? I mean,
It's a great question, and I think that there has to be a source for it because the NRK pathway is upregulated in some of the conditions in which, for example, in heart failure in the mouse and in human, there's a decline in cardiac NAD and there's an upregulation of nicotinamide riboside kinase 2. So I think that that's telling us that there has to be a source for NR. It may be there's some local process where cells are blowing up and contributing their NAD coenzymes, which break down to NR and then go into the cardiac cells. There's a lot of interesting cases in biology where, like, a glial cell or astrocyte will provide mitochondria or some nutrients for a neuron. And I think that there's some system to be discovered in which some cell type is contributing their NAD coenzyme pool for cells that are undergoing some type of metabolic stress to pick up NR and to kind of rebuild their cellular supplies.
do you see CD38, I mean, which is one of the biggest consumers of NAD, as something that we should try to inhibit or not as we get older?
I don't think we know enough about it to want to inhibit it. Mice that have mutations in CD38 have been used as a model for autism spectrum disorder. I've done some experiments with them. So I'm not going out there with any intention to inhibit my CD38. I think that's one of those very suspect ideas like, let's get rid of all our senescent cells. I don't think that's a great idea. I think that we have cells that are senescent in order to be prepared for certain types of infection, and we have CD38 to do signaling functions that relate to oxytocin and calcium handling. And no, I'm not in favor of inhibiting CD38.
Just one kind of level deeper on that. I mean, if ordinary, like me, if I was going to try and inhibit CD38, I mean, I would not be doing it either genetically or indeed with some kind of drug. I would be maybe using epigenin, which may reduce it, but it certainly isn't going to remove it. I mean, would
I don't
that
know. I
change
don't
your
think you
thinking?
know enough about that to do it.
You don't.
I don't think you should buy apigenin and take it. I don't know what it would contain if you were to do that. I just think those are not good ideas.
Okay. If you're taking NR, it may raise your nicotinamide. Should you also be thinking about having a methyl donor in case you use a lot of methyl groups to remove the
No,
nicotinamide?
I think that, this conversation is now moving into the area of podcast disease.
Right?
So, so, so when people start talking to me about they want to inhibit their CD38 or they need methyl groups, or I think that they've listened to people that are far more confident than they have a knowledge base to be. Um, m- you know, everything that we eat is a methyl group donor. And the fact that taking nicotinamide riboside leads to excretion of methylated nicotinamide byproducts in urine doesn't mean that you're methyl deficient. So no, you don't need trimethylglycine.
Cool. Are there any proven ways to raise NAD through lifestyle?
No, I don't think so. I mean, if you were to live in a sealed bubble that protected you from all viruses, I think you would have other problems. Um, so I don't recommend people become germ phobes or go around with masks on their face or have monitors for to make sure that they sleep exactly 8 hours. I think that most of those things are nutty types of biohacking that don't make any sense.
Well, there was a paper from Janssen that showed that I guess people who did lots of exercise had higher NAD than
That's
people who.
great. Yeah, I
So,
mean, but you know that exercise having higher NAD is not the end. The goal is to be more fit, right? So you exercise to be more fit, and then it boosts every system in your body, including the NAD system, the circulatory system. You get more skeletal muscle mass, so you have better glucose disposal. You can have a longer, set of episodes of lovemaking with your partner, which boosts your every aspect of your wellness. So all of these things help, right? You don't need to go and test your NAD and see whether exercise improved it or whether Niagen improved it. These are just parts of a lifestyle that make you well.
right. Yeah, your general wellness is what matters, not
Right.
would your NAD level be some way of some measure of your general wellness?
Your, um, I mean, yeah, I mean, I would say that there are ways to see an inflammatory signature. I mean, like the people with mitochondrial disease have, an NAD defect. In people with an active COVID infection have, in addition to a bunch of inflammatory markers, they have depressed levels of glutathione and they almost certainly have some altered NAD, metabolites, that are indicative of an attack on the NAD system. But then if people are supplementing with Niagen, they're going to have elevated NAD. So if someone has a cold or infection and they they take Niagen 8 hours later, they're going to have higher NAD levels, but it doesn't mean that their cold is resolved yet. So I just think that the biomarker world, you know, is built on false premises. Like I never recommend that we do, you know, DNA methylation aging tests in our experiments because the basically what a lot of groups do is they choose 4 or 5 different kits and then they publish the one that gives them the result that they're looking for. And there are all sorts of known artifacts in that literature. Like there's one that was published a couple of months ago where they took football players in England. I don't know if they were semi-pro soccer players or something like that. And they take a DNA methylation age test and then they go out and they play ball for 2, 3 hours and then they take another age test and it looked like they were all quote older, right? Because they just started sweating and they had some type of inflammatory reaction that created this methylation signature, and then in a day or two they went back to what they were before. Well, this just proves that the DNA methylation tests do not test your biological age. They were perfect at the end of the game. They were sweaty. They were better off before the game in terms of what they were doing for their fitness. And this just gives you, I mean, it gives the whole story away. Like all of these publications that people had, oh, COVID ages you 10 years. And then you test them again when they the infection is resolved and it goes back to what it was before. No, COVID didn't age you 10 years. Your biomarkers during COVID were inflammatory, and the test is reporting on inflammatory biomarkers. End of story. It's not your age.
Yes.
A measure
Sorry.
of a thing is not
Yeah.
the same as the thing, right?
Yeah. But thinking about biomarkers, we don't, I mean, there's no way that you can feel what your LDL level is, right? We do have some biomarkers that seem to be correlated, although people
Yeah.
continue to argue about them, seem to be correlated
So
with outcomes.
ApoB and LDL cholesterol are really important. And I think LDL denialists are a real problem. When you look at Twitter and people say, "Oh, I'm red pilled or whatever," and now I don't believe all this stuff about saturated fat and LDL. I think that's really really dangerous. So I mean that stuff, atherosclerotic mechanisms depend upon ApoB and LDL particles and, you know, PCSK9 inhibitors lower not only those biomarkers, but they lower cardiovascular events. So that's something that has a known value. There's a known value proposition there. There's a known value proposition of blood pressure. But if you're measuring NAD, the people that have low NAD are people with mitochondrial disease that already know they have a mitochondrial disease. And everybody that is taking Niagen is going to have an elevated NAD level in their blood, which the functional things it's doing for you, let's measure them functionally. Like if the person has peripheral artery disease, you should be able to improve their walking speed. But measuring NAD itself is not an actionable biomarker unless somebody didn't know that they had mitochondrial disease and discovers a problem in this way.
Yeah. So yeah. So my LDL example was really it was just an example of what biomarkers you would think are really important and actionable.
Yeah.
Yeah. Okay.
Well, here in California, I'm a member of Kaiser, right? And their whole goal is let's take care of the population without breaking the bank on any one individual Kaiser member, right? And so if they measure it, it means there is a use case for it. They started a medical school down the road in Pasadena where they teach evidence-based medicine. These are the numbers that we care about because they're going to drive clinical decisions. And we're going to send people emails if they have elevated or too low levels of these things. And the things that we wouldn't send them an email about, we don't even want to measure it, right? So they're not going to start measuring NAD. They're just not.
Right. Yeah, I hadn't
So
thought about that.
all it would do is it would tell them uh, who is taking a B3 supplement. That's the only thing it would tell them. And they could just ask us, which they do.
Yes. Yeah, I mean it's interesting, especially for insurance companies because they're money driven and which is good, right? So that it makes sense that they would want to measure only the things that really matter, that they can see matter in their data, which is interesting. Okay, so actually I wanted to return. I've been thinking about Psalm one, NMN. So NMN, I think, gets broken down when you take it.
Mhm.
So I don't think if you take NMN, it raises the NMN in the blood. So it wouldn't directly get into the neurons and
Right.
raise the NMN
I agree with you. But strangely, there's groups, a very prominent group, Shinimai at Washington University in St. Louis, that claims that there's an NMN transporter. So claims that NMN gets taken up intact into cells. I don't see how that could be. I've looked at their data. I've formally challenged their data because I believe that the data show that SLC 12A8 is a sodium transporter and not an NMN transporter. But I'd like somebody to explain to me if NMN is transported intact, why it wouldn't cause neurodegeneration. Now, the other problem with NMN is that, you know, if you have to, as a chemist, go to the trouble of putting the phosphate group on to form NMN, and then someone takes it orally and it breaks down to NR, then why did you take NMN in the first place? And then because NMN is being tested as a drug by Metrobiotech, it's not clear to me that it's safely available to humans because the DSHEA law, DSHEA law, says that if something is introduced as a food slash supplement, like NR was, it can subsequently be tested as a drug. But if something is initially tested as a drug, like NMN was initially registered for clinical trials as a drug, then it's not supposed to be available to consumers. So I'm not sure that there is a safe kind of consumer supplement form of NMN. And there are independent groups, like the group in Singapore, that have opened up bottles of NMN and tried, more than 10 of them and not found a lot of NMN in these supplements. So it's probably not effective because it's probably not really being sold as a pure supplement.
Okay, we'll, yeah, yes, I saw that report, yeah, from Andrea Meyer's team. I think that some of the NMNs on Amazon had like zero NMN. Yeah. But there have been other tests, like I talked to a supplement testing company, and they said for creatine, there's a very similar thing. You can buy
Oh,
creatine off that has zero creatine in.
yeah. Yeah. So Niagen, is a company that focuses on Niagen, and they license the IP, the original IP from Dartmouth, where I discovered the uses of nicotinamide riboside. They patented or they licensed synthesis of NR. They then licensed a crystal form, and they're devoted to, safety testing. They provide the same material to investigators that are doing clinical trials that people can buy. So, I mean, that's the safe way to do NAD boosting is with Niagen NR. And the disclosure is I am the chief scientific advisor of this company. They initially licensed my IP from Dartmouth. That IP is no longer in force, but I continue to be an advisor of the company. But I'm happy and proud to be an advisor because this is a conservative company. They don't go out and they say that it's going to extend people's lifespan. We don't call it a longevity drug. We don't make those kinds of claims. We're really backed by the clinical trials that establish the safety, establish the efficacy as an anti-inflammatory agent in 8 trials, indication of cerebral blood flow in Parkinson's, the peripheral artery disease, walking speed trial, and others. So I think that this is a company that you can trust.
Thank you. Yes, NR does have the most human trials, I think, of these boosters. Okay, Dr. Brenner, thank you so much for joining us.
Really a pleasure.
Where can people follow your research?
So they can look at my lab at brennerlab.net. They can ask me questions on Twitter or X, as it's now called, at Charles M. Brenner. My middle initial is M. And yeah, if they have questions, they can at me on Twitter, and I'll do my best to respond to the best of my abilities. And a lot of times I'll tell you I don't know, right? As I did today. I don't make things up. I don't make, you know, ostentatious claims, but I think that this is an evidence-based supplement. It's been safety first in terms of its development. And I think it really does have a proven use case going forward.
Thank you. So thank you so much for joining us today.
Thank you.